Welcome back, guys. This is our math help video on how far our objects are flying. What is the max height they obtain, provided we know their time to reach the top. All right, let's take a look at our data. So question 1, we have Greg the evil scientist devises a water bottle rocket of his own making. He tests the rocket and records the following data. Your group's eventual rocket data should look similar to this. Calculate Greg's max height, his rocket reached, and the initial vertical velocity. Show your work. All right, so step 1, let's just see what we have here so far. Our start time, this is the time that it left the ground. The time at the peak, we got both these from our cell phone video. All right, and then finally, our total time is just equal to the end time minus the start time. Okay, so that's how we got that. Calculate the maximum height reached. Show your work. Well, height reached is how far, right? So we're looking for using this equation down here. All right, so let's write that equation. Distance equals 1/2 gt squared. All right, we have 1/2 times g. G is always 10, right? 10 meters per second squared. Then we have time squared, so you just do 4.3 seconds times 4.3 seconds because we have this nice squared term right here. Okay, we'll let you guys plug in to solve that. Use your calculator. 4.3 times 4.3 times 10 times 1/2, and you'll get your answers in meters. That's how high Greg's rocket flew. All right, question B says calculate the initial velocity that the rocket launched with. Okay, in particular, we're dealing with the initial vertical velocity because we'll find out with two-dimensional motion, if an object's moving like that, it's really made up of a vertical component and a horizontal component to the velocity. All right, so step 1, what equation do we want to use? Well, velocity is how fast, right? So we are going to go ahead and use this equation right here. We have our vertical velocity is equal to our initial velocity plus acceleration times time. Well, in this case, our final velocity is 0, right? Because this is the time we used up here was the time to get to the peak. So this is really the peak velocity. So we have 0 equals the initial velocity plus a times t. Okay? And so we manipulate this a little bit. We subtract the initial velocity on both sides. Okay, we say v initial, negative v initial equals a times t. All right, in that case, we have v initial equals g times t. All right, in particular, we say that g is negative, right? It's a negative 10 overall times t. All right, we have a negative on this side, negative on that side. We'll cancel them out. So we have v initial equals 10 meters per second times our flight time, 4.3 meters per second. Okay, and so we have our answers 43 meters per second. All right, pretty good, Greg. All right, we'll do this on our own data a little bit later. All right, see you guys later.